So here we are again. My name is Jonathan. I'm a product manager with AutoForm. I'm here with Kevin and Jonathan again at Piper Aircraft, PIMCO. And we'll do another quick introduction about PIMCO.
So I'm Jonathan Hilton. I'm the project engineer at Piper Industrial Manufacturing Company, or PIMCO. What PIMCO is the Aerostructures division of Piper Aircraft, focusing on third-party contract manufacturing services.
Very good.
So my name's Kevin Chisholm. I'm the new business development manager for PIMCO.
Okay, so we're now at the press, or one of the presses. We've got a little bit to know about their process for development in our previous video, and we're going to touch on at least one example of where you've kind of made some strides and what you continually try to improve in your production processes. So tell us about your particular process. You mentioned blanks being as one of those key important shapes. So how do you arrive to that shape? Why is it important?
So yeah, it's really a good question. So this is one of our better examples of how AutoForm has brought a lot of revolutionary technology to our forming process, right? So this is actually the part in question. It is the lower door pan of the PA-28 aircraft. This part before AutoForm, we had about a 58% success rate, yield rate. Primarily, we would have a lot of wrinkling that would occur in this area over here that then the operator would then hand work out. Okay. So you can see this is actually a redesigned tool for the area. And let's not kid ourselves. This is kind of a difficult part. You've got a lot of things going on here.
No.
You've got this area over here that has multiple contours going towards it. You have this joggle. It's also in compression, and it's in shrinkage as well in several areas. So because of the AutoForm technology, we were actually able to develop the draw dam in here, and you can kind of see carefully where the material actually flows in. And that's when we're talking about how a lot of our material flow and our flat patterns dimensioning comes from. So it's not about cutting the shape to the 2D pattern of the part. It's about getting it to where when it's formed, it comes into that 3D shape.
Right.
So this is a redesigned tool. It's actually a multi-step tool. So we're going to do two operations on this. The first part would just go in there, it's going to draw itself around, and then we actually have this guy in here that's our intensifying pad for the second hit, which will get out all this
flange here. And if you can't see, you can see how much curvature there is in this part. It's aluminum. There's also a slight twist in the bend line as you look down the part. So appearances, it's easy. But so what you're describing is this wasn't the original tool.
No.
This added bar, which what I would call the effect of having like a slip pad, that was the addition that you were able to come to this new countermeasure, make the change to the tool, and now you have a better running part. And I didn't hear the percentages that you used.
Yeah, so the initial yield was 58%.
Okay.
And now we're way above 95%.
Okay.
So it's also minimized operations. It's a better fitting part. It passes inspection. It gets down to assembly, and it goes right into the aircraft.
Okay. So this sets on the second hit.
Yes.
This should fit down into that.
Yeah, and there's a lot of spring back that goes on with this. So yep, you can get it to sit in there, but it's still got a lot of pop up and backs, which is by design. So instead of just trying to cut it net and then just hoping it comes out like this, because of those spring back tables that we're talking about, which are just tables, especially when you get into all the twists and the bends and the contours that we're talking about, especially with this part, really can't just rely on simple spring back calculation for something like that.
So this tool is cut to nominal, or it has some bend?
There's lots of spring backs, absolutely.
And you're using your estimation of what to put into the tool from both simulation and experience, or just simulation?
The experience gets you started, and then the simulation tells you exactly where to go for the last little bit.
And as simple as this part looks, there's a lot of complicated stuff going on. And as you can see with a standard die, there's an example right here. But the standard die where it's just a 90-degree angle, whatever that bend angle is, they're fairly complicated, or fairly simple. So, spring back calculation is easy. You start getting into complex contour shapes, spring back is a lot of experience is necessary to get something
right. And hopefully everybody can hear at home. This is we're in a real production environment, so there's no way to get around that. Now this part is also not finished yet, right?
No, it's going to get primed. It's going to get primed, painted, and installed in the aircraft. But no more third-party meaning. Like that is ready to go on the aircraft.
Okay.
In terms of shape.
And it's part of your charge for Piper is this isn't just a one tool kind of thing. You're going through different parts to see what you can do with what you have that's running now to improve quality or reduce operations.
Correct. So yeah, we actually are in the process of a initiative for tooling to go look at all the parts and see where our highest scrap rates are. So we're using data to say, all right, why are these parts yielding so much scrap? And can we look at them? So we're using the simulation software to look at those parts and see how we can reduce that. And again, this is a huge win for us. So we're looking at parts a lot like this.
Okay.
We have a full tool team here. We have a in-house 4 tool designers, and they're constantly designing, fabricating, making changes to tooling. But yeah.
And that's certainly, we'll say, also an improvement on your efficiency on what you're using AutoForm for, because I can't imagine. I mean, how many new parts do you design in a year?
Thousands.
New parts?
Well, not new parts. So going over old parts and trying to
Okay.
optimize that process. But along with new parts, there might be thousands.
Yeah. So
On roughly 170, 180,000 parts through our hydroforming machines a year.
Okay.
So it's a lot of parts that run through here. So high flow volumes, and there's a lot of mixing, a lot of part numbers.
now one of the things our team does a lot of is we do a lot of manufacturing consulting work in a lot of ways. So, we do have a few programs going on where we're doing some design for manufacturing and assembly concepts. So we do a lot of just, hey, is this even going to work?
Mhm.
So that we know that when we've got tools a year from now or 2 years from now or 5 years from now, we know it's going to work. So we're reducing our risk during some of the developmental processes so that we can actually then have a manufacturable process later downstream.
Makes sense. You're building some of your fundamental experience with what happens. You have the method down, you have the material files. Later on, you just apply it.
Correct.
And do you do similar type of work, consulting work for other companies?
Correct. That's the PIMCO. Yes. And a lot of our companies that we are currently working with, we are actively using simulation. So when they discuss a part with us, we can tell them a high degree of confidence that yes, it will work, or no, it won't work.
Mhm.
And then we'll offer some design changes that they might need to make on that part.
Okay. And that's for not just aerospace also, right? You're doing work for automotive, aerospace.
Correct. We're currently in the process of working with a couple automotive companies now,
Okay.
with some R&D type work.
Okay. Well, I think that's another good snippet of how you guys are making some pretty big strides. You've only been using the software for,
Right out of a little over a year now.
okay, so very quickly you've kind of driven your experience level up, I would say pretty high, and that seems like you're very active. That's,
And I would say once we got this software, we saw the value of it, and our tool design team went from a team of 2 to now a team of 4 in that short period of time. Because again, we see the value of AutoForm and the simulation.
there used to be a day when nobody believed simulation, but I don't know.
I know that. And this is a good example of how it works.
Yeah, just the way that sits on there now in the free state, you kind of you cringe a little bit.
Correct.
But thank you guys again for your time.
Yep.
And thanks for watching.
Thank you.
Thank you.